questions 11 through 20 on the 2005 Grade 10 Cayley Math Contest. During a football game, Matt kicked the ball 3 times. His longest kick was 43 meters, and the 3 kicks averaged 37 meters. If the other 2 kicks were the same length, the distance in meters that each traveled was. So we have 3 kicks. We'll call them X, X, and 43. And we are told that the average, if you divide by 3, is 37. So this is the math equation. So this gives me 2x plus 43 is equal to 3 times 37, which is 111. And therefore 2x is equal to 68. And therefore x is equal to 34. So each of those kicks that was equal in length is 34. And therefore number 11, the answer is D. The lines y is equal to minus 2x plus 8 and y is equal to a half x minus 2 meet at 4, 0 as shown. The area of the triangle formed by these 2 lines and the line x equals minus 2 is. All right. Let's see here. Where would you like to begin? Well, this is 4, 0, and this is the origin right here. So from here to here is 4. And therefore, from here to here has got to be 2, because this is x equals minus 2. So this distance is 2. Okay? Now we've got 2 triangles. That one and this one. If we can figure out both of those heights, since we know the base is 6, we can figure out the areas of those 2 triangles. All right, so to figure out the base, that's just 2 plus 4. But to figure out the height, I'm going to need to know this coordinate right here. All right, well, that is the intersection of x equals minus 2 and y is equal to minus 2x plus 8, those 2 lines. So substitute one into the other. So I've got y is equal to minus 2 times minus 2 plus 8, and therefore that is 4 plus 8, and therefore y is equal to 12. So that's 12. So this distance here is 12. So in a very similar way, we have to find that point right there, and that will allow me to get that distance. And how do I do that? Well, what are the 2 lines? It's x equals minus 2 and y is equal to x over 2 minus 2, like that. So we've got y is equal to minus 2 over 2 minus 2. So y is equal to minus 3, like that. So this is minus 3, but obviously the distance is going to be 3 because you can't have a negative distance. So now we have everything we need to solve the area. It's 2 triangles. The first one is 1/2 base times height, so 6 times 12. And the second triangle is 1/2 base times height, which is 6 times 3. So this looks like 3 times 12, which is 36, plus 3 times 3, which is 9, and that adds up to 45. So number 12, the answer is E. A 400-meter track is constructed so that points A, B, C, and D divide the track into 4 segments of equal length. The start is halfway between A and B. Andrew begins at the start and walks at a steady rate of 1.4 meters per second in a counterclockwise direction after exactly 30 minutes. To what point will Andrew be closest? 1.4 meters per second times 30 minutes, but 30 minutes I'm going to change that to seconds, and that is 30 times 60 seconds, which is 1,800 seconds. So 1,800 seconds. And this is 2,520 meters. So he's going around this track 2,520 meters in distance. Now, he starts right here, right? So it's a 400-meter track, so every time he walks 400 meters, he's going to come back to that same point. So if I divide this by 400, it'll give me an idea of how many times it's 6 times with a remainder of 120. So he's going to come back to that start 6 times, but then he's going to go another 120. All right. He's going to go another 120, so approximately here. That's where he's going to end up. Now this track is 400 and those letters divide it equally, so from A to B would be 100 meters. So that means from the start to B is 50. And therefore, since he walks another 120, from B to this point that I drew is 70. Correct? So they want to know which point is he closest to. Well, it looks like he's closest to C. So number 13, the answer is C. If x is a positive integer less than 100, how many values of x make the square root of 1 plus 2 plus 3 plus 4 plus x an integer? So 1 plus 2 plus 3 plus 4 plus x is an integer. So that is 10 plus x. Now x is between what? It's less than 100, but it's positive, so it's got to be greater than 0. So we can only use values of x between 1 to 99. All right? Okay, not a problem. So we've got to make this guy an integer. So first and foremost, I'm going to write out what are the numbers that if you put them underneath the square root sign would become an integer. And those, of course, are numbers that are perfect squares. So numbers like 16, 25, 36, 49, 64, 81, 100. Okay, now I don't need to go beyond this or less than that because my range for x is only from 1 to 99. So for each of these perfect squares, what would x be? Well, to get 16, my x would be 6. To get 25, my x would be 10. To get 36, my x would be 26, and so on. Now, we have to write these out and see if they fulfill our criteria, which is right there. 71 and 90. And they do, right? If I go further, let's say I go to the next perfect square, which is what? 11 times 11, 121. X would be 111, and that's not part of this criteria. So that's why I can't use that. So these are the only values of x that if I put them into this equation, the result will be an integer. So how many do I have? 1, 2, 3, 4, 5, 6, 7. So number 14, the answer is B. Starting with the 2 in the center, the number 2005 can be formed by moving from circle to circle only if the two circles are touching. How many different paths can be followed to form 2005? So I've got this diagram, blew it up a little bit. Now, what's important to remember is that you start right here, right, with the 2, and then obviously you're going to go to one of these zeros. So since we have 1, 2, 3, 4, 5, 6 possible choices, I'm going to label them, let's use letters A, B, C, D, E, and F, all right, just to distinguish them. So the very first scenario, I'm going to start with A, the circle, or the circle that I denoted A, and that's got a 0. Now, if I go from 2 to A, so far I've got 2, 0. But I've got to get 2, 0, 0, 5. Okay, so from A, I've got to get another 0. So I can go either here or here. On the diagram, that would mean from this 0, I can go either here or I can go either here. Because I can only go somewhere that's touching. Now at this point, I still don't have my full number. The full number is 2005. So once I'm here, I've got to get a 5. How do I get a 5? Either here, here, or here. So I'll draw that in my diagram over here. It looks like 5 like that, 5 diagonally, or 5, I guess, to the northwest, perhaps. And then very similarly, for this guy, to finish off that number, I've got to get a 5 either here, here, or here. Correct? So that means the 5 has got to go here, here, or here. So how many different paths did I get, starting with that original 2, which was here, I guess? I got 1, 2, 3, 4, 5, 6. So for letter A, 6 paths, like that. Okay? Now the good news in this question is that if you do the exact same scenario for B, you will get 6 paths. It'll be pretty much exactly the same. And guess what? Same holds true for C, and for D and E and F. Each of them also give 6 paths. So since there's 6 of them, and each of them gives 6 paths, the total number of paths are 36. So number 15, the answer is A. The non-negative difference between two numbers A and B is A minus B or B minus A, whichever is greater than or equal to 0. For example, the non-negative difference between 24 and 64 is 40. In the sequence 88, 24, 64, 40, 24, ... each number after the second is obtained by finding the non-negative difference between the previous two numbers. The sum of the first 100 numbers in this sequence is. Well, the first few they've given you, 24, 64, 40, 24, and so on. So let's keep going here. Next one will be the non-negative difference between 40 and 24, and that looks like 16. The next one, the difference between 24 and 16 is 8. The next one, the difference between 16 and 8 is 8. The next one, the difference between 8 and 8 is 0. The difference between 8 and 0 is 8. Difference between 0 and 8 is 8. The difference between 8 and 8 is 0. Let's keep going here. The difference between 8 and 0 is 8. The difference between 0 and 8 is 8. And the difference between 8 and 8 is 0. So it looks like I've got a little bit of a pattern going here. 880, 880. Okay. So I've got to get to the 100th number. Now, obviously, I'm not going to sit here writing out 100 numbers. So we can just use the fact that we have got a pattern. The first, how many do I have here? 1, 2, 3, 4, 5. The first 6 numbers are here. And then I've got a repeating pattern of 880, 880. So I've got to figure out the sum of the first 100 numbers, right? So out of the first 100 numbers, 6 of them are accounted for. So I've got 94 left. Now, of those 94, they're all going to be patterns of 880, 880, 880, like that. So this 94, I'm going to divide by 3. And that gives me how many of those 880s there are going to be. See what I mean? 880, 880, 880, like that. How many of those? Well, 94 divided by 3, unfortunately, is not an even number. It's the 31 remainder 1, like that. So that basically means that you've got 880s 31 times, right? ... all these. And then at the very end, you've got one final guy, one final number, and that would be an 8, right? Because it's 880. So there you go. Those are the numbers. Now I've got to figure out the sum. Okay, the sum looks like 88 plus 24 plus 64 plus 40 plus 24 plus 16. And then I've got 31 of these 880s. So 8 plus 8 plus 0. And then at the very end, I've got that final 8. Okay, let's figure this out. So I got this here, 256. Then 31 times 16, right here. which is 496. And then I've got that lone 8 at the very end. And 256, 496, and 8 is 760. So number 16, the answer is B. 10 to the power of 100 is a Google. 1,000 to the power of 100 equals. Google, of course, is our famous search engine, spelled slightly differently. And Google started in 1998. The internet began in Canada in 1994. Yahoo, if I remember, started in 1995. Now, what's interesting is, when I first learned the internet in 1994, there was no Yahoo, no Google. So what search engine did I use? Lycos. Most of you watching this video have never heard of Lycos. I think Lycos still exists if you go type it. And there was another one called Alta Vista. These are search engines that existed way back in 94 when I was in undergrad. And it's amazing how Google came along actually a little bit later, but then eventually took over the entire world. And Google bought YouTube, and the whole world is on YouTube. It's actually the #1 most visited website on the internet. All right, going back to the question, we've got 10 to the power of 10 is equal to a Google, right? So we want to figure out 1,000 to the power of 100 in terms of a Google. Okay, no problem. The 1,000 here I can write as 10 to the power of 3, like that. All to the power of 100. So this becomes 10 to the power of 300. And then I can factor that again as 10 to the power of 100, all to the power of 3. Just rearranging the numbers. Now 10 to the power of 100 is our Google, and that's all to the power of 3. So there you go. Number 17, therefore, the answer is E. Harry the hamster is put in a maze and he starts at point S. The paths are such that Harry can move forward only in the direction of the arrows. At any junction, he is equally likely to choose any of the forward paths. What is the probability that Harry ends up in B? Okay, let's just use the diagram here. From here, he's got 3 possible ways to go, and each of those is equal probability. So 1/3, 1/3, and 1/3 probability. And then once he gets to here, he's got equal probability of going either here or here. So each of those has got to be a half, and a half. Once he gets to here, there's only one way to go, and that's obtained with a full probability of 1. Once he's here, he's got 3 possible directions, and each of those is an equal probability of 1/3. And there you go. So what we want is, how do we get to B? Well, we can either get to B like that, or straight down like that, or like that. Okay? And then we have to add up those probabilities. So the first one is 1/3 times a half. Add to that, the second one was 1/3 times 1. And add to that the third one, which is 1/3 times a third. So this gives me 1/6 plus 1/3 plus 1/9. Getting a common denominator, 18 I believe, so that would be 3 plus 6 plus 2, and that looks like 11/18. So number 18, the answer is C. In the diagram, AB is 13 centimeters, DC is 20, and AD is 5. The length AC to the nearest tenth of a centimeter is. Okay. Well, let's see, where do we begin here? Well, first, let's figure out BD. We can do that using Pythagoras. BD squared plus 5 squared is equal to 13 squared. And therefore, BD squared is equal to 169 minus 25, which is 144. And therefore, BD is the square root of that, which is 12. So BD is 12. Put that in there. Okay. Now at this point, I think it's helpful if we extend this a little bit. I'll draw a parallel line like that, and then a line that goes down like that. And if you do that, it will help out, because you'll notice that since this line is exactly like BD, it has the same length, 12, and therefore if I can figure out this distance right here, I can be sure that I can figure out AC, which is this diagonal. To do that, I'll figure out BC. BC I can get with Pythagoras on this triangle right here. So that would be BC squared plus 12 squared is equal to 20 squared, like that. So BC is going to be 400 minus 144, and that looks like it will be 256, and therefore BC is equal to 16. All right, I think we've got everything we need. So if BC is 16, then this side is also 16, since that I drew a rectangle essentially. All right, let's figure it out. Now we've got this triangle that we're going to use to figure out AC. So AC squared is going to be 12 squared plus this whole length right there, which is 5 plus 16, which is 21 squared. So that's 144 plus 441, which is 585. And therefore AC is the square root of 585. And if you do that, you get approximately 24.2. So number 19, the answer is A. There are 81 cars in the CMC parking lot. CMC is Canadian Mathematics Competition, which are all Acuras, Beetles, or Camrys. There are half as many Acuras as Beetles. The number of Camrys is 80% of the number of Acuras and Beetles together. How many of the 81 cars are Beetles? I will denote A, B, and C for Acuras, Beetles, and Camrys respectively. And the first sentence, or I guess the second sentence, they tell you that there's half as many Acuras as Beetles. So mathematically, that basically means that B is equal to 2A. Then the next part, they tell you that the number of Camrys is 80% of the number of Acuras and Beetles together. So Acuras plus Beetles together, and 80% of that, so I guess 4 over 5, is equal to the number of Camrys. So that's our second equation. And then the last equation you can get from the last sentence, which is that there are 81 cars. So that means A plus B plus C is 81. And they want you to figure out how many Beetles are there. So they want you to figure out B. Okay, let's move forward with this. Let's see, where do you want to start here? Many ways of doing this. Okay, the first thing is I'm just going to substitute everything in terms of B. So this equation 81, instead of A, I'll put B over 2, because that is what A is equal to. Okay, and plus C. Now, C I can probably get in terms of B as well using that equation. So C is equal to 4 over 5A, but A I can write B over 2 plus B, like that. So there you go. Instead of C here, I can just put 4 over 5 B over 2 plus B, like that. Okay, so here we go. This looks like 3B over 2 plus 4 over 5, 3B over 2. And then this would be 3B over 2 plus 6B over 5 is equal to 81. All right, we got to get a common denominator. So let's see here, that would be 10. So that's going to be 15B and 12B. So 810, if I cross multiply, is 27B. And therefore B is 810 divided by 27, which is 30. So there are 30 beetles in the parking lot. And therefore number 20, the answer is B.